So sound as a wave, when it hits a solid object, it reflects back. So the angle of incidence equals the angle of reflection. Now this technique is used by some animals. Bats, for example, have eyes, but they don't see. They're actually blind. Yes. So bats emit the sound waves, and the sound waves hits the object in the way of the bat, and it reflects back, giving him the shape and the distance where it is from the object. So either it will avoid it or just hunt it if it was a prey, and this gives it the preciseness of hunting prey. This technique is used by man in order to see inside the embryo of a pregnant woman. So the parents may see the picture of their baby, if it was a boy or a girl or whatever, just see the image of the embryo, and it appears on the screen like that. So that the sound waves hit the embryo and then they return back, giving the image of the embryo. Another thing about sound is hearing the sound at daytime and at night. So if you are talking to somebody in an open area at daytime, it will be hard for him to hear you. But at night, it will be easier to hear you. Regardless of all the noise and pollution, we are just talking about sound and air. So if you have a ground and there's somebody standing here, another one standing there, and that one is talking to this one, the sound waves will move like that, upwards. And this will make the sound harder to hear. So the air layer, which is near to the ground, is warm, and accordingly its density will decrease. It will be relatively less than the density of the air layer, which is upwards. So we'll have two air layers, one near the ground, which is warm, and the upper one will be cool. So when sound moves throughout this air, it will deviate, or it will refract upwards. So this will make the sound harder to hear. But at night, the situation is the opposite. The layer of the cold air is near the ground because the ground has lost its heat. There's no sun, and the warm air has evaporated upwards, and it went upwards due to its low density. So the cold air will be near the ground and the warm air will be upwards, and so the sound refracts downwards, which makes it nearer to the ear and easier to hear. Did I just try? We know that sound waves are transverse waves, and transverse waves mean that they contain compressions and rarefactions. So when two sound waves interfere with each other, the compressions and rarefactions of both waves meet together. So at the parts where the compressions meet the compressions, or the rarefactions meet the rarefaction, this is called a constructive interference because it enhances the power of the wave, increases its frequency, velocity, and so on. But when the rarefactions meet the compressions of another wave, or vice versa, this is called a destructive interference because they are not the same, and accordingly they lead to making the wave more weaker. That's why it's called destructive interference. So this makes kind of a pattern and draws a certain shape. Let's see the next video.
When I turn this on, you'll see it produces circular waves. They simply spread out from that point there, more or less constant speed. There's a little bit of dispersion, but very little, and so you see the waves spread out in a circular fashion. That's not particularly interesting. It gets more interesting when we put the second source in. And now we have the two sources in phase producing ripples, one there and one there. And you can see fairly clearly what happens in this case. There are places where the waves add up, i.e. you get constructive interference. For example, along the line perpendicular to the line joining the two, you'll get constructive interference and you'll always get a maximum. A little off to one side, you'll see that you get destructive interference. The waves are out of phase there, they cancel out. And similarly over here, they cancel out.
So that's it for today, and until the next time, I thank you for watching and see you. For the previous video about resonance, click on this link. And for the other videos of definitions, proofs, and stuff like that for physics, click on the other video. And for subscription, click on the logo. Thank you.